Hello and welcome to TEQ. I'm your host, Carolina Milanesi, and today is a very special TEQ for me because I am close to home. I am at Georgia Tech, and I want to cover, I think, a topic that is very hot in the industry right now, which is the semiconductor business, but more importantly, the future of engineering in the U.S. And Georgia Tech is certainly striving to be the go-to place for anyone who wants to become an engineer and looks at the semiconductor industry as their future. I'm here today with two professors and also the chair of the Steve Chaddick School. And I'm going to let you introduce yourself so that I don't incur into what people do with my last name, which is mess it up. So I'm starting with you.
Thank you so much, Carolina, for being here. My name is Arijit Raychowdhury. I'm the Steve Chaddick School Chair. We are here in the Electrical and Computer Engineering building in Georgia Tech. Visvesh.
Thank you, Carolina. My name is Visvesh Sathe. I'm an Associate Professor here in the School of EC here at Georgia Tech.
Thank you very much for spending some time with me this morning. I started paying attention, and this sounds terrible as a Georgia resident, but I started paying attention to what Georgia Tech was doing over the past year or so, and really looking at two initiatives in particular. One is you are, as a school, part of the new Apple Silicon Initiative, but you're also working with Nvidia on AI. And I want to start there with these two areas, silicon and AI, which are so intertwined, and then kind of broaden up the discussion.
Sure. So I think in ECE in particular, but Georgia Tech overall, we have worked with the industry for many years. I think this is not new that we will be kind of working with some of the best companies in the world.
And you both have a very tech background.
Yes.
Intel, Qualcomm, AMD.
He's AMD. I was Intel before the TI. So yeah, we have covered some of the major companies in our past life. But yeah, I think the whole idea was kind of the relationship with Apple is essentially on the semiconductor side, where we have been partnering with Apple for almost 3 years now. And recently there was sort of like an inflection point where we took our relationship to the next level with the new Silicon Initiative program. And the whole idea is to get students more hands-on experience on whatever they're working on. So semiconductors, if you take the Apple initiative as a case study, the main thing here is for students to be able to get an opportunity to build silicon as a part of a classroom experience, which is super hard if you really think about how much design effort and time and expertise is needed to be able to build working silicon. So we are super excited that this 1 year kind of a course, the first semester and the second semester, the students are actually able to tape out a microprocessor, get it back, and do testing and write software for that, and so on. And Visvesh is the person who has led that effort, and we have amazing interactions with Apple now as we are kind of making that program stronger and stronger. And on the other side, with respect to AI, I think the big initiative on campus, which was last year, was essentially, again, this was a few years in the making, but the idea was we launched the first Makerspace, a virtual Makerspace with Nvidia. The idea was all universities are investing in AI research and education, and we have been doing that as well. Everybody is kind of making sure that our students are well calibrated with what's going on in the space of AI, because AI is kind of another great tool, right? Not only for engineering but for other disciplines as well. And the idea was to be able to give students the power of computing, because that's what the tool of AI is. And we launched this AI Makerspace, which is with the latest NVIDIA GPUs with support from NVIDIA. And again, a result of a close partnership with NVIDIA, where the students on campus now have access to one of the largest supercomputers for AI, purely for education. So first-year undergraduate student coming out of high school has access to more computing than most medium-sized companies do. So I think this is super exciting for us. And we are already seeing a lot of success stories in the last 1 year on how students are using it in ways that we never envisioned that, that's how they're going to use it. So yeah, I think these are great two initiatives that we have been kind of working on the last couple of years, apart from many other, industry partnerships that we also have.
I'm curious, oftentimes you see the names of the big companies funding something. How far does their partnership goes though? Is it just about money and a name to a program, or do they get involved in curriculum and hands-on on campus with the students?
So I'll let Visvesh talk a little bit about that.
No, that's a really good question, and remarkably so, because in the case of Apple in particular, sure, as Arijit mentioned, there's a reason why, this is not, until recently, this has not been a widely offered course across the country or even in the world. These things are logistically very complicated. They're expensive. So you do need the money, as you rightly pointed out. But Apple's been remarkable in the sense that they have really put in their time, commitment, the time of their engineers to really making this a success. It's not so much about, here's the money, tape out what you have, and we'll see how it goes, right? They're really backing it to the help with getting their engineers and coordinating with us well in advance about, hey, what kind of lectures would complement your offering effectively. They're very, conscious about being able to provide the most support they can, with the goal of providing the students sort of the knowledge and a course experience that is as compelling as it can be within, of course, course boundaries and what Apple can divulge naturally, right? It is a company. And they provide that in terms of lecture support. They are also, they visit, I think, at least once every semester to do Q&As with the students. And this can range all the way from very detailed technical questions in the domain space of one of the engineers that actually comes down to visit, all the way down to sort of general engineering career advice, right? And this is very, very useful for a lot of undergrads who are only beginning to see the landscape, both educationally, technically, and career-wise. So that is, we're grateful for the money, that's great. But what's very special in particular is the time and effort that they put into it.
I love that, because oftentimes we focus on the skill set and the knowledge from a technical or expertise perspective, but then how do you go about actually getting in the market and in the business is missing. So I like that. So all that said, what I'm curious about is, obviously from a semiconductor perspective, there's a lot of change undergoing, and especially with AI becoming part of the design from a chipset perspective. And I'm curious, if you're looking at emerging trends in engineering and technology more broadly, what you see shaping the future of engineering, and in particular, where you need to focus going forward from a teaching perspective?
Yeah, I think that's a great question. And I don't think there is a good answer, because, the future is the future. It's uncertain. So I think things are changing, and I think changing at a very rapid pace, particularly with AI. As you rightly pointed out, I think AI and the use of AI for many of the tasks that we do are going to be there everywhere. It's kind of becoming the norm. So we are using AI for, a lot of the classes. There are new classes which are teaching AI. A lot of the new advances in AI, particularly in generative AI, needs a lot of data. So having a lot of computing resources is becoming more important. And we are trying to provide the students with as much resources as they can. Semiconductors is also evolving. I think a lot of the work in chip design and all has been going on for a while. And I think there is now more interest in packaging and package substrates and materials, and how do you integrate more and more chips on the same packaging substrate. So that's a big area of focus for Georgia Tech and the industry and the world at the moment. Apart from that, I think all these data centers are consuming a lot of energy. So sustainability and energy usage is a big area, right? So I think that's a big area. So how do you build systems which are sustainable? And on the energy side, I think that's a big, the state of Georgia has been super focused on clean energy, right? I think that's a big investment for us as a state. And so Georgia Tech is kind of trying to do its part to kind of educate the next generation of students to understand sustainable energy and energy usage distribution with both traditional sources and intermittent sources, right? So that's a big area. Atlanta is becoming a hub for healthcare. I think that's a big area. So our bioelectronics and the bio area is kind of evolving and developing quite a bit. There's a very strong tradition of taking research from the lab to the market. And so that's also happening in multiple areas, bio being one area where I think we have seen a lot of success stories in the last few years. And then again, I think there are areas which are of national importance, national security interests, like cybersecurity. I think that's a big area for us. We have hired a lot of amazing faculty, and we have students, graduate and undergraduate, working in the space. That's a big area for us. We also have a very strong portfolio of like research going on in wireless. I think that's again, because we are very strongly connected with the Georgia Tech Research Institute that works very closely with the government. We do a lot of work particularly with the graduate students on the research side, which is fundamental research on future G platforms like 6G and beyond, both for commercial as well as for military use. So again,
there's no AI, there's no connectivity.
Absolutely, I think So I think AI is a part of the bigger ecosystem, but more importantly, I think all areas are getting impacted by AI, but they're also very traditional engineering disciplines which are seeing huge changes because of all the new investment that's going on on these areas. And electrical and computer engineering, for better or for worse, is in the crux of all of this. It's in the middle of everything that's going on. So it's kind of interesting to see how I think we were kind of students around the same time, how the experiences have changed when we were students versus for our students now. But yeah, I think there are many areas where Georgia Tech and EC are kind of trying to play a leading role, I'd say.
And you mentioned just now some of the areas, and it was interesting as I was waiting to start this, I was chatting about my 17-year-old who, crushed all my dreams and said that they will never make it into Georgia Tech. But that aside, sometimes you talk about tech and people get lost a little bit about the opportunity. You say engineer, and people don't really know how far now tech goes and how far being an engineer is going to take you. I'm curious about, as you think about curriculum and really applied learning, how are you thinking differently about working with your students?
Yeah, you'll take this.
Yeah, that's a really good one. I think I in the past, and I still do struggle to articulate sort of where education leaves off and where vocational training takes over. And there's a huge overlap, and they're still very distinct, right? And Arijit was talking about the various ways in which AI is going to influence a vast number of other research and educational areas that Georgia Tech is strong at, and how it will influence that in the future. And I think at the end of the day, as a matter of sort of personal perspective, I think the best we can do is provide sort of a rigorous educational experience and equip them to then go off and be creative and be very solid about how they sort of look into the future and adopt technologies as they arrive at their doorstep. So if you're doing wireless, if you're doing circuits, if you're building hardware, there's a lot of ways in which AI workloads are different and that they influence what we do, how we build hardware. There is some value in teaching to that because that's what the job market wants, but that maybe will future-proof you for the next 5 years. But if we want to really build amazing engineers, that rigor there is no replacement for, but the application provides a great testing ground to give them a complete experience all the way from education to sort of application and sort of realizing that goal. And sure, if we can sort of make them very compelling candidates for the workforce, that really ends up being a byproduct.
Yeah.
That's sort of my view on it. I think you might have sort of...
No, yeah. I think, yeah, absolutely. I think this is, at the end of the day, I think technology evolves very fast and it is evolving very fast. So I think the role of education is to provide you with the necessary tools that you need to be able to adapt in life. I think that's the purpose of education. It's to be able to have the courage and the confidence to face the unknown, right?
Yeah.
I think that's the role of an educator, and it has always been the role of an educator. Like when we were students, our teachers learned in systems with vacuum tubes and whatnot, and things changed, right? And they gave us the right tools and the right background information, the right rigorous way of thinking about engineering and education, so that we could do whatever interesting things we want to do. So I think that's our role, and I think things will keep on changing and evolving. So we have to be open as educators.
I love that, because I think that sometimes you try and chase in the technology and you're always going to lose in that way, right? Because the technology is moving too fast versus actually providing the skill set that will apply to whatever technology there is. If I think about high school or even elementary school where we're talking about coding, it's not actually coding, because AI is going to be doing some of that for us, right?
Mm-hmm.
Is really more about troubleshooting and critical thinking that you're learning through coding. I'm curious, as we're talking about skill set, how much, I'm very strong on, I hate the term soft skill. It's really more about, this podcast is all about EQ. So that emotional intelligence that comes into technology and has to be there, especially as AI is going to start dominate. Is that something that you think of when you're teaching here at Georgia Tech?
Yeah, I mean, since we're talking about AI and EQ, so I'll give you an example, which I think is a great example. So this year we started a new minor in the College of Engineering on AI. So any student who's coming into Georgia Tech will be able to do a minor in AI. So this minor in AI is a joint partnership between the College of Engineering and our Ivan Allen College of, which is Humanities and Language and Media Policy. So if you think about, we are also started a new course for a 2000 level course, which is for freshmen and sophomores on AI. And 1/3 of that course is about, understanding AI in the context of society and ethics and practices and how do you navigate the gray areas that we don't know, right? So I think it's pretty much at the forefront of education in Georgia Tech. Of course, we want to be able to teach the students the engineering principles and all, but with an understanding that that this is going to be eventually applied to human society. So human lives are at stake in some cases. So it's important to kind of understand the implication of what you're working on. So a lot of our students are super passionate about, sustainability. We talked about it, and, and how innovations in the area of energy usage and energy storage and all that kind of impact society. We have a bunch of different programs, again, avoiding the word soft skills, but I'd say which are essentially going to allow students to become better in their own professions, right? So, and also remember that, this generation of students that are going through our system now spend their high schools and maybe the final year of their middle school home because of the pandemic. So their skill sets in terms of socializing and all did suffer, absolutely. And I think the college, particularly when they came back to college, we provided more resources for students to be able to kind of engage with their peers, with their educators. There are we have also serious investments that we have done in making sure that the students, when they need help, mental health related help and all, there are resources on campus, lots of resources on campus. So we are trying to kind of make sure that we have become very selective in getting students, but once they're in, we are trying to make sure that they have all the resources needed, both on the technical side as well as on the non-technical side, so that they become good engineers. Which is, good engineers just don't do math, right? So they also have to be very good in communicating. They should be good in working with others as a team and understand the metrics of success are not necessarily numbers. So I think those are the kinds of skill sets that we are trying to provide. And I think many of the engagements that we have with our industry partners allows them to do that, because they understand that a career is not something which is linear. It goes through many non-linear transformations, and it's a long path. So I think they can understand that the ultimate satisfaction in a career does not necessarily come from your pay stub, but there are many other things that are part of that journey. So I think we are trying to be as open to these conversations with the students as we can.
Everything you said is just music to my ears, because having been in as an analyst in the industry for over 20 years, I know very well what it's like to talk to an engineer, but always starts with the technology first versus the societal part first. Just because it can be done from a technology perspective doesn't mean that it should be done. And I think unless you develop those societal and really empathetic skills, it's hard to distinguish the two. I'm curious, obviously, you're preparing the future of technology through your engineers. How do you use technology on campus to help you do that?
You can take that.
Yeah, I think with regard to the course, for example, this theory to tape out class where the students build their own processors, we adopt a lot of the standard technologies that are available as you would expect in any modern classroom. The students collaborate heavily on teams. They occasionally meet up, but a lot of the collaboration is done on teams. They heavily adopt sort of best practices methods in terms of how they maintain their designs, things of that nature. But in terms of sort of using broader, I think the question was, how are they using technology to further this goal? I think about that. Other than classroom,
maybe maybe I can.
Let me think.
I think this. I think first thing you have to realize that our instructors and faculty their median age is about 20-30 years more than the students, right? So the students use technology better than we can.
Well, I don't know what you mean.
So the students use technology a lot better than we can or we do, right? I mean, when I teach or from my graduate students, more often than not, I learn a lot, right? So what the new platforms are, what the new tools are, and so on. So I think, and I think Georgia Tech was one of the first universities that said that if you're writing your college essay, it's fine to use AI. I mean, you feel free to use ChatGPT, but you have to kind of acknowledge that you have used ChatGPT, right? Just like when you acknowledge that you're using external help.
And that's important, right? Because you're teaching them to use the tools in an ethical way.
Absolutely.
Embracing that.
Yeah, it's like using a calculator, right? It's a more sophisticated calculator. And then when the students do, for example, technical writing today in Georgia Tech, everybody has to do technical writing. As in EC, we have multiple courses that teach students how to do technical writing. They're using language models. I think so what we are teaching them is essentially our professor who teaches that course. She is teaching them to write better prompts so that you can understand, whatever you're getting from ChatGPT may not be right. So you should be able to go back and check. So in Visvesh's class, he talked about using platforms for people to kind of come together, Teams and other virtual platforms. But other than that, I think the places where we are using technology also, I think, is on the operations side as a large institute. I mean, it's a big institute with a huge amount of operating cost. So we are trying to be better in both in HR, in payroll, in terms of logistics, in terms of maintenance of our research contracts and grants. So we can do a lot better there. But I think there is some appetite from the institute to kind of consume some of the resources in particularly in AI and automation to make some of these processes better. So we are kind of embracing that as well.
Yeah.
That's reminded me, yes. So yeah, Arijit reminded me of one other thing we have. There's a stated policy in the class that, and this is only going to deepen over time. You're more than welcome to use GPT or any generative AI tools towards your design assignments as well. You have to reference it. You have to declare that you've used them. You are ultimately responsible for the outcome of what you produce, both in the assignments as well as in the fabricated chip. If there was a bug and you missed it, you can't really point to the tool and say, well, my tools were broken, right? So that's definitely a key component of it. I see the students already using it in the verification of their designs, in writing a lot of the scripts to really strengthen their productivity, improve their productivity when it comes to checking that their design is right. I expect over time, it will continue to evolve and account for a greater portion of the design construction effort. And as that happens, it'll be exciting to see how it happens. It'll also be interesting to see sort of what pitfalls show up. But that's sort of part of the fun of it all.
Yeah. We are almost at time, but I'm curious, before I let you go, if you're thinking about where the semiconductor and generally the technology market is moving, what are you most excited about and what are you most concerned about when it comes to preparing your students?
That's a great question. Actually, you're talking specifically about semiconductors, right?
Semiconductor in particular, yeah. As an AI, maybe if we want to broaden it to that.
So the intersection of these two, I think, are kind of a critical area. But I think with semiconductors, there's a lot of excitement in the last, I'd say, 5 years. There was a lull, I'd say, for about 15 years before that, where we did not pay a lot of attention to manufacturing. Which has resulted in most of the manufacturing going outside of the US, except for a couple of foundries. So we are kind of understand that that semiconductors is almost like a currency at the moment, and having deep expertise and talent it doesn't come in a year. It will take time and investment in generating a pipeline of students over the next 15 years, 20 years before we can have manufacturing back. So the fact that we have investment in the Chips and Sciences Act, I think, is a great positive, move. I think it was great to see that. As far as semiconductors, on the technical side of things, I see a lot of interesting opportunities, particularly in integration, like in packaging substrates. There are lots of new applications that are coming on, particularly on both on the edge, with people's, what you're getting into people's hands, but also on the data center side. On the data center side, I think a lot of the investment in the future has to be on sustainability, and how do you make sure that your data centers do not consume 20% of your GDP, right? So that's where we are going at the moment. So I'll give you an interesting anecdote. So if you look at the trajectory of total consumption of power from the data centers, if you look at the trajectory over the last 10 years, and if you just do an extrapolation, by 2040 we will have to consume as much energy as you can collect from every photon that comes from the sun. So if you collect all the photons coming from the sun, the total energy from the solar system, you'll just be able to meet the energy requirement of all the data centers. So that's not possible, right? So essentially that means that we have to rethink how data centers are built. We have to absolutely invest in better, more efficient semiconductor technologies, but not semiconductors, but the whole ecosystem overall. I think that's where I see a lot of excitement, which allows us to kind of innovate and work together with other disciplines and really be at the forefront.
Which is why I love that as part of your teaching.
Oh, yeah.
As, you're starting, because I think that's where we need to be, right? We need to be at a point where from the design, we're already thinking about sustainability. Because otherwise it'll be too late. It's already late now.
Yeah. So I think to your point, you being an Atlanta native, we have a very strong partnership with Southern Company and Georgia Power. As a matter of fact, Georgia Power Georgia Power is a subsidiary of Southern Company, and they have a microgrid on campus. So on the TSRB area, that Tech Square area, there is a microgrid, and that powers a large part of the data center. So what happens is, the students and faculty can actually understand the whole interaction between a power grid and a data center and our, consumption, and kind of close the loop. So you can use it for interesting research opportunities. You can use it for understanding how to scale up and essentially understand the whole ecosystem, that, that power is not something that comes from a plug. It comes from some physical resource, right? So I think I feel there is a lot of excitement in that whole area of understanding how semiconductors, computing, sustainability, security, all of these things will play a role in our future society. And AI is going to accelerate a lot of these things and make things, just very good and very bad. Like, very good in certain aspects and very bad in certain aspects in terms of, energy usage and all. So yeah, I think this is a great time to be a hardware engineer and a semiconductor person, because after many years, I again see, this is my area. So I feel very excited that I'll be excited to work for the next, 15 years, 20 years. And there are no shortage of problems to work on. So it's
that's for sure.
Yeah,
yes.
It's a great area.
And I'm excited that your focus is so encompassing, that is so broad, and it really looks at the entirety of what an engineer should think about and must think about, really. So thank you so much for the time today. I really appreciate it.
Thank you so much.
Thank you so much.